Let's reverse everything. Let's go and determine the standard form of the equation of a parabola with given details. In the previous practice exercises, we're able to graph the parabola and determine the important parts of it. We started with the vertex. We also determined the focus, the directrix, the latus rectum, and even the ends of the latus rectum. Right now, for this practice exercise, our goal is to reverse our operation. Instead of determining all of these necessary details, our goal is to use this to determine the standard form for an equation of the parabola. We only have two forms for an equation of the parabola. We have here this form, x squared is equal to 4py, corresponds to a parabola that is either opening upward or downward. The second form of a standard form for a parabola is you have y squared is equal to 4px. And this is now the standard form for a parabola that is either opening towards the left or towards the right, or as a whole, it opens sidewards. With these informations, we can determine the standard form of the parabola following any of the two. But look at what is actually common to both of them. Aside from the variables x and y and the constant 4, what is common to both of the standard form is the presence of p. In this case, for items 1, 2, 3, and 4, before we could give the standard form for the equation of the parabola, we need to determine first what is the value for p. If you have read your module or research on other references, or even tried to view the previous three videos, we all know that the focus, the directrix, the latus rectum, and even the ends of the latus rectum contains the value of p. They are just placed differently. So with this idea here, we already have focus for number 1, latus rectum for 2, we have the ends of the latus rectum for number 3, and the directrix at number 4. All of this contains P already. Our goal is to determine what is the value for P. Let's look at number 1. Number 1 is the vertex is located at the origin, and the focus is located at 10, 0. If we do have vertex at 0, 0, we are already given that the focus is actually given with either two forms. It's either given as P0 or 0p. The only difference between the two is if I talk about p0, it opens towards either the left or the right, but 0p, it opens upward or downward. Just by looking at it, what fits more is this comparison here. But if you're not solved with that sort of analysis, you can just simply try to graph them in a separate piece of paper. Vertex at, let's use black colored line. Let's assume that these are Cartesian plane. So the vertex is at 0, 0. The focus is at 10, 0. 10, this is x coordinate and y is 0. So 10 would become 1, 2, 3, 4, 5, 6, 7, assuming 9, 10 here. So the focus is somewhere here. If this is the focus and this is the vertex, please do not forget that the focus is always on the interior of the parabola. So if we're going to draw the parabola, it should contain the focus. This is not what is the parabola. It also doesn't open downward, and it doesn't open towards the left. It should open towards the right. So by knowing that it opens towards the right, we can determine the correct form of the focus. And that is actually this form here. You might want to review your module for this. It is in the form P0. So the focus is at P0. And since our focus is 10, 0, the value for our P here is given to be 10. Again, since the focus is at P0 and it's given here that is actually 10, 0, our P is equal to 10. Now that we have the value for P and we know that it opens sideward, we are going to use this for number 1. So we have here the equation y squared is equal to 4px. And P is 10, so simply substitute. You have 4 times 10x. So the standard form for number 1 is given to be y squared is equal to 4t x. Again, how it was made into this is by first getting the value for p, and second, deciding on which of the two forms is more applicable. And we decided that it's the second form because in our partial computation or draft here, it looks like the graph is opening towards the left, to which the second form falls into. So this is our answer for number 1. For number 2, still the vertex at 0, 0, but we do have here the idea that it actually opens downward. So if it opens downward, we are now sure that the standard forms in the form x squared is equal to 4py. So earlier we started with P and decide on which form is fit to number 1 by with this draft here. But right now we are already given with the direction. Our goal is to solve for P. We have here the value for the lattice rectum. The lattice rectum is the length of the line segment containing the focus. And its ends, again, are points of the parabola. The formula for the lattice rectum is actually absolute value of 4p. And then we just simply need to compare them and have this equation. Absolute value of 4p is equal to 4. To solve for p, take note, we do have here absolute value equation. So we have two cases. First case is 4p equals to positive 4. Second case, 4p is equal to negative 4. So we have two values for p. P, sorry, p can be equal to 1. And the second is p is equal to negative 1. So we have here two values for p. However, we need to decide which values should be substituted here so that it will become the standard form will become the form of the equation will become the standard form. And what is it? If you're going to substitute the value for p here, you will have the equation x squared is equal to 16. That's 4 times, 4 times 1 is 4, and then y. If you're going to analyze this form here, the expression or the coefficient rather here is positive. So when you're going to when you're to graph this rather, it should open upwards. But we already given here that it should open downward. The hint here is if it opens downward, we are sure that the coefficient here should be a negative value. That's why we don't use this, but rather we use the value negative 1. So by using negative 1, our equation for the standard form is actually x squared is equal to, let's use the red color so to be consistent, x squared is equal to 4 times negative 1y, which will actually result to x squared, this here, is equal to negative 4y. And then since it has a negative coefficient here, it conforms to the given that it should open downward. This is the correct equation in standard form of the parabola. Okay, so we are done with number 1 and 2. Let's proceed to number 3. So the vertex is at 0, 0. We don't have the direction for the parabola given here, so any of the two could be possible. What can help us here is the determination for the ends of the lattice rectum. The ends of the lattice rectum, if we're going to plot them in the Cartesian plane, we have two ends here. We have -2 and +4. We also have -2 and -4. So it's actually located somewhere here. -1, -1. Sorry, rather -1, -2. So you have 1, 2, 3, 4. That's the second. 1, 2, 3, 4 here. So if these are the ends of your lattice rectum, what does your lattice rectum look like? A vertical or horizontal line? These are the ends. In short, our lattice rectum should be a vertical line. And what is the implication if it's a vertical line? If it's a vertical line, the parabola should open towards the left. Why? Because the focus is located on the lattice rectum or the line segment here, which is actually um, part of the length of the lattice rectum, and it's the interior of our parabola, and the vertex is here, so it opens towards the left. What is the purpose for this? The purpose for this is to decide which form best fit the situation. So since it opens sideward, we will use the second form, which is y squared is equal to 4px. Now that we have dealt with this, the form, let's look at p. If you're going to review your module and that our parabola here is opening towards the left, our ends of the lattice rectum is given to be equal to p and then plus minus twice of p. This is the ends of the lattice rectum if the parabola opens sidewards. If we're going to compare to this to the value for p is -2. Look at this one. We have p plus minus. So if we're going to break it, you have p positive 2p, and you have here p and negative 2p. If we're going to compare to the two here, look at what happened. Our p is -2, and our 2p is either our positive negative 2p. This one is either positive negative 4. So we are now sure that our p for number 3 is actually a negative value. Aside from that, we are also sure that it's negative because once we substituted it here, you will have y squared is equal to 4 times -2x. You will have the equation in standard form. Y squared is -8x. Look at the coefficient of 8, or x rather, it's -8. It Since it's a negative coefficient, that is another proof that it opens towards the left. Look at our graph, it conforms to that, and that is correct. Finally, for our last item here, we are given with a situation that our vertex is still at the center. By the way, I do have here the area for graphing. So I have you may also place this here. Okay, I forgot that I have here a graphing paper. You could place number 1 here for your analysis as well as for number 3. But since we already have them here, let's continue for number 4. For number 4, it's still vertex is still 0, 0. Let's use this. Okay, vertex is at 0, 0. The directrix is y equal to positive 6. Why? If it's no, no, not the question why. I mean the variable y. Y is at negative is positive 6. If we have this equation of a line y is equal to 6, it means it is a straight line passing through 1, 2, 3, 4, 5, 6 on the y-axis because its y is equal to 6. So if it passes here, therefore our directrix is actually a horizontal line in this area here. Okay, so it should be somewhere there. Yeah, this is our directrix, and this has the equation given to be y is equal to positive 6. And what is this for? Look at our goal, P. This P, as I've mentioned before, is the distance from the vertex to the focus and also the distance of the vertex to the directrix. Since the vertex is here, we have 1, 2, 3, 4, 5, 6. The value for our P is more or less equal to 6. Okay? It is equal to 6. However, look at this one. If our directrix is here, our focus is on the opposite side. -1, -2, -3, -4, -5, -6. This is where our focus is. So if this is where our focus is, our graph should open downward. If it opens downward, we can trim down already. We'll be using the first, okay, because it opens downward. So you have the equation here, x squared is equal to 4py. This is now our form because it opens downward. But if we are going to use p is equal to 6 here, look at what will happen. You have 4 times 6y, and you will have x squared is equal to 24y. It's positive. So it should be opening upward. This is the reason why I'm telling you P is not necessarily equal to 6. But take note that it could also be negative of 6 because the directrix when it opens downward is equal to y is equal to negative P. And then y is equal to 6. You have y, right? Y is equal to 6. You could say that negative P is equal to 6. So P is equal to negative 6. Let me repeat. This is now the form. Okay, I just sort for analysis for our directrix for an opening downward parabola. And since we already have here y is equal to 6, we can I just simply pair them. Y is y, and therefore negative P is 6. Take them out. Divide both sides by -1. P is -6. This is your true value for your P. Okay? And then as we substitute it to our equation here, you will have 4 times -6y. This will yield to an equation x squared is equal to -24y. This is now the correct standard form of an equation. How is it done? The point here is analyze properly the value for p, and for that you could use all the given. You could say you could use the focus, plot them here, directrix, lattice rectum, the ends, and then analyze where it open the parabola should open somewhere, where it should open somewhere rather. So whether it's up or down, left or right, this could trim down your options here between the two, and this could also trim down the possibility for the value for p, to which you will need in substituting to the equation that you have chosen. So this is what this video is intended for. Please use this as part of your review and see you for the next one soon. Goodbye, everyone.